Hello, bachcho. In this question, it is given that let I is equals to root of minus 1. If minus 1 plus I root 3 to the power of 21 divided by 1 minus I to the power of 24 plus 1 plus I root 3 power 21 divided by 1 plus I to the power 24 is equals to k, and n is equals to the greatest integral part of modulus of k, then we have to find the value of summation j equals to 0 to n plus 5 j plus 5 square minus summation j equal to 0 to n plus 5 j plus 5 is equals to. Now for this question, let us write the key concept. Here the key concept is e power I theta can be written as cos theta plus I sin theta, and e power minus I theta can be written as cos theta minus I sin theta. Let us use this and solve the problem. Here we have minus 1 plus I root 3. This, if we multiply and divide by 2, we will get 2 into minus 1 by 2 plus I root 3 by 2. This can be written as 2 into cos 2 pi by 3 plus I sin 2 pi by 3, which is equals to 2 into e to the power of I 2 pi by 3. Now we have 1 plus root 3, I root 3, that is 1 plus I root 3. If we multiply and divide by 2, we will get 2 into 1 by 2 plus I root 3 by 2. This is equals to 2 into cos pi by 3 plus I sin pi by 3, which is equals to 2 into e to the power of I pi by 3. Now we have 1 minus I. 1 minus I into, if we multiply and divide by root 2, we will get root 2 into 1 by root 2 minus I into 1 by root 2. This is equals to 2 into cos pi by 4 minus I sin pi by 4. This is equals to root 2 into e to the power of minus I pi by 4. Now we have 1 plus I. So if we multiply and divide by root 2, we will get root 2 into 1 by root 2 plus I into 1 by root 2, which is equals to root 2 into cos pi by 4 plus I sin pi by 4, which is equals to root 2 e to the power of I pi by 4. Now let us substitute these in the given equation. We have the given equation as minus 1 plus I root 3 to the power of 21 divided by 1 minus I to the power of 24 plus 1 plus I root 3 to the power of 21 divided by 1 plus I to the power of 24, which is equals to, we have the value 2 into e to the power of I 2 pi by 3 to the power of 21 divided by, for 1 minus I we have root 2 into e to the power of I minus I pi by 4 whole to the power of 24 plus 1 plus I root 3 is 2 into e to the power of I pi by 3 to the power of 21 divided by root 2 into e to the power of I pi by 4 to the power of 24. We can write this as 2 to the power of 21 e I to the power of 14 pi divided by 2 to the power of 12 into e to the power of minus 6 pi I plus 2 to the power of 21 into e to the power of 7 pi I divided by 2 to the power of 12 into e to the power of 6 pi I. Now we can write this as 2 to the power of 9 into e to the power of 20 pi I plus 2 to the power of 9 into e to the power of pi I. 2 to the power of 9 into e to the power of 20 pi I is 1 plus 2 to the power of 9 into e to the power of pi I is minus 1. So we get 2 to the power of 9 minus 2 to the power of 9, which is equals to 0. So we have n value is equals to 0. Now we have to find summation of j is equals to 0 to n plus 5, that is 0 plus 5. 5 into j plus 5 whole square plus summation j equals to 0 to 5 j plus 5. If we substitute the values of j from 0 to 5, we will get 5 square plus 6 square plus 7 square plus 8 square plus 9 square plus 10 square. Then in the question we have minus. So minus 5 plus 6 plus 7 plus 8 plus 9 plus 10. If we subtract this, we will get 355 minus 45, which is equals to 310. Now the answer is 310. Hope you understood the solution. Thank you, bachcho.